Okey, siapa-siapa dah dapat jawapan semalam? Apa jawapannya? Apakah objek yang terus-menerus bergerak dengan garis lurus, bergerak lurus, tidak bengkang-bengkok, terus lurus, walaupun tidak ada enjin, walaupun tidak ada internal force, external force, both not applied on the object, but still the object keep moving with uniform velocity and in straight line. So can you come up with one example?
Cahaya.
Cahaya is not a matter. We talk about object. When we talk about object, that is a matter. What is a matter? A matter is the thing occupied space and do have a mass. When things have occupied space and have a mass, then is what we call matter. While light is not a matter because it is occupied space but it has no mass. Okay, so other thing that you can think of about inertia, anyone? It is a star sheet. Star sheet. We call star sheet. You do know star sheet? Star sheet. In science they call a meteorite. A meteorite. A proof to this inertia, which is the meteorites move at uniform velocity. Even 100 years, even 1,000 years, even million years, as long as they travel with no external force, even internal force exert on them, they still keep moving even a million years. And if the internal or external force doesn't apply on them, they will keep moving infinity time, because all of the matters in the world obey Allah's command. All of the matters in the world obeys Allah's command, which is Allah's command for those who begin at rest. You must remain at rest until external force exert on you. And for those who begin at uniform velocity, I command you to remain at uniform velocity until internal or external force being exerted on you. This is God's command. Do you understand? We know that, you know that already. You learned science form 3, the last topic. Do you remember the last topic? Science form 3. Which the how far the stars located from our Earth. How far? They took million years of traveling from our planet. And we know that the stars, some of them explode to die, to become black hole. You know the process. And once it's explode, the pebble will travel, will be spread all the way 360 degree, and all the pebbles will start moving with a uniform velocity. Some of them travel at 20,000 kilometer speed. Some of them travel at 30,000 kilometer speed per hour. Some of them will be travel more than that, the speed. So they will keep moving. All of the pebble will keep moving. All of the is what we call a part of a star that exploded is what we call the pebbles. All the pebbles is what we call a meteorite. A meteorite is a small part of the star which has been exploded. All of them will spread all around the world, and they will keep moving in a straight line with a uniform velocity. And how long they will travel? How long? They will never ever stop. They will never ever stop. How do we know? Because the meteorite that enter our planet, you know what? Who bring them to us? Who bring them to us? Which transport that they use to come from a star which located million years far from our planet? Who deliver them? Which transport that they have to come to our Earth? How do they able to reach our planet, even located million years the distance? How do they travel to our planet? How do they reach to our planet? So you know what? They travel all along. They do not require an engine. They do not require internal force, that is engine. They do not require external force, that is somebody keep pushing them to move. They just need, all they happen to them is they keep moving. They obey the God command, which is telling them to keep moving. Once they moving at uniform velocity, then they need to remain keep moving at uniform velocity until their path somehow been blocked by other planet. Some of them they blocked by sun. Some of them blocked by the moon, our moon. Some of them blocked by Jupiter. Some of them keep moving along in a straight line and enter our atmosphere and eventually been stopped by our planet, that is Earth. Until then, they will still keep, they will stop from uniform velocity. So now, do you understand now? What is the inertia? Somebody? Any question about this? Inertia? Still don't understand or what? Everybody, do you understand? You know what? This is why they, in science fiction, they telling us that it is a very efficient in order to save energy if we live in a space. If we live in a space, it is a very efficient to save energy. You know why? Because we know in space there is a vacuum. Vacuum means nothing at all, empty space, not even a single atom or molecule of gas, no air, nothing at all. It's what we call vacuum. It is very efficient if we move through vacuum. Why? Because this is you. Okay, you want to go there, to the right side. This is your school. Okay, your school. Where? Okay, your school. You and your school is in space, which means between you and the school has no matter, nothing at all, empty space, vacuum. So the distance is, let's say the distance is 10 kilometers. 10 kilometers. So how are you going to go that way to the right until you reach at this school? You just can fly, you know. You just need to fly all the way here in straight line. All you need to do is, at first, you only jump once. You have to do only jump once, and your body will, when you begin at a uniform velocity here, because you jump, you start uniform velocity by some force, that is you jump. Okay, you jump. And how long will it travel? How long will it travel? Because you know that there is no air, nothing at all to stop your motion, to stop you from moving. in a straight line. You know what? You will keep moving. You will keep moving ever and forever in a straight line with a uniform velocity. So you will keep moving with a uniform velocity, because nobody going to stop you, means that there is no external force going to stop you, and you obey, and your motion obey God command, that is whatever moving at uniform velocity will keep moving at that uniform velocity until somebody disturb you, until external force disturb you. But in this case, nobody going to disturb you. This is why you remain at uniform velocity as earlier until you reach this goal, which has something to stop you. So you know what? Instead of your father come in our planet here, so your father need to take you. You need to get on any vehicle. Let's say your father's car, and you, of course your father will keep press the petrol oil in order to move the car, means that the engine required the energy from petrol oil to do the things, to move all the parts in engine, and then eventually rotate the tires. Okay, and it required but you know what, if your father stop pressing the oil pedal, it seems that the car will eventually come at stop a couple moment. Why? Because why your father will, and the car will come at stop. Why? Because in our world there is not only, not end here, but there is many external forces, such as what? Such as air resistance. So I kind of illustrate air resistance like this, to become a atom and molecule. This is what external force that exert on your car, and try to stop the moving of the car to the right. Okay, and other external force that exert on your car is the friction between the road and the tires. We got a friction. Do you know friction? Okay, which drag this car from moving to the right side. The friction always opposes the moving of the object. If object moves to the right, the friction will go to the left. If the moving go to upward, the friction will go downward. The idea is the friction always opposes the motion the direction of the motion. And actually, there is also the friction inside the engine itself, inside the engine. So some of the oil, about 20 or 30%, will be a waste. Will be a waste. 20 or 30% will not be turned to rotate this tire, but they will turn to heat and sound instead of rotate this tire. Okay, so the idea is there will be many external force exert on your car, and actually on other thing inside our planet, in order to stop moving object. This is why we see that in our experience, start from our living as a baby until now, we tend to see that anything that move from earlier will come to stop after some time, because the planet that we are living, which do have a lot of external force, which waiting to stop all kinds of motion. Different than this, in space here, this is why scientists, physicists thought about this. If we can somehow build our world in space, guess what? We could reduce how many energy we could reduce in order to travel from one point to another point. Doesn't matter how long it takes. Doesn't matter, because you need to jump only once. Then the motion just leads to inertia to do until we reach at the destination that we want. Okay, now do you understand about inertia? A long story to talk about inertia, because you got no experience at all about inertia unless you live in a space. Okay, so that what happened in a rocket, in a hub of rocket, in a room of rocket. Here they are, the astronomer, they live inside this hub, let's say like that. So they kind of want to test this inertia. You know what? They try to throw something forward. They try to throw something forward. They try to throw pen or pencil, even a small velocity, and they see that the pen or pencil keep moving in a straight line. Sorry, outside here, they throw it outside here in this vacuum. Here not a vacuum, because got air inside for breathe. Okay, they throw the pen on a vacuum here, space here. Then guess what? Even the velocity is low, but they see the pen is keep moving. Keep moving to the right side here in a straight line. Straight line. And they wait for a couple minutes. They see the pen still keep moving. Still keep travel in a straight line like that. They waiting if the pen want to stop, but guess what? The pen keep moving afar from them ever and forever. Why? Because nothing in this space going to exert force to this pen. So this is why this pen have no reason to stop from uniform velocity that the pen has. It will keep moving until, who know, one day, million years, thousand years later, somehow this straight line somehow intercept to don't know which planet, and then the pen will start being exerted by many force in the planet in order to stop this pen from motion and so whatever. Okay. So there is some activity which we can do even in our so many external force here in order to prove this concept inertia. Simple one that you can do at home like this. You have a glass filled with water, or if not filled with water, empty glass is okay, doesn't matter. And then you put a thin cardboard up there on the top of the glass, and then you put a coin there on the top of the cardboard. Okay, and then you try to jerk this cardboard as fast as you can. So what do you think might happen to this coin? Let's say you jerk this thin cardboard to the right side. What do you think might happen to this coin? Somebody? Amna? What do you assume will happen to the coin? Takif? Amira? What is it?
Selain daripada dia sendiri.
Akan apa? Tak dengar. Syatira?
Tak bergerak.
Tak bergerak. Maknanya dia akan duduk kat situlah. Koin tu akan tetap di situ walaupun cardboard sudah tarik ke kanan. Tasnim? Any idea? Any idea? What will happen? What will happen?
Kalau koin tu jatuh dengan lambat?
Siapa dia nak jatuh dengan lambat pula? What will happen? What will happen? Somebody? Any idea?
Kejap.
Kena air.
Apa dia? What will happen?
Jatuh air.
Jatuh dalam air.
Jatuh dalam air lah kan. Dia bergerak juga, tapi dia bukan bergerak ikut. Kamu nampak cikgu buat? Tengok ni. I got mouse here. A mouse here. Lepas tu, you know what? I will jerk this a piece of paper to my right, to my front side here. Guess what will happen to this mouse? Do you think will it follow this? Will it follow this paper to my front side here? I'm going to do this as quickly as I can. So you'll see. Can you see?
Yes.
Again. Do you see? How about other thing? How about this pen? Okay. About this pen. Okay. If you see it move even a slide, it is not initial fault. It is my fault because I do not jerk as fast as I can. Do you understand? It should be as the faster the better you see the initial. So it's supposed to be like this. Okay, stay right there. Okay, because all of them follow the concept of inertia, the concept of Allah. Okay, guess what? We maybe think that this coin, if we jerk this thin cardboard to the right side, we think that this coin should follow the cardboard to the right side, whichever we pull the cardboard. But once we do this activity, we'll see that the coin remain at rest. The coin before we pull this cardboard, the coin remain at rest, correct? And once we pull the cardboard, we suppose this coin to start moving to the right side. But you know what? This coin telling us that he want to obey God command. That is, he want to remain at rest. Because the force that exert not to him but to this thin cardboard only. So this coin tell us that why he need to follow this cardboard. I want to remain at rest by following God command. That is inertia. So do whatever to this thin cardboard as quickly as you can. I will still remain at rest. And yeah, of course, because this here has no thin cardboard after we jerk this, and there's nothing to uphold this coin, is why this coin as usual back to follow the gravity, the attraction of gravity, and that make this coin start falling inside the glass. Okay, there is another concept, the concept of falling object because of attraction of gravity. But the idea is the coin resist. The coin resists to move to where this thin cardboard move. Okay. Okay. Moving along. Here come the new subtopic, and that is recognizing recognizing the relationship between inertia and mass. What is the relationship between inertia and mass? If what, then what? What happened to mass, then what will happen to inertia? If what happened to inertia, what does it mean to mass? Okay? So we'll see this photograph. We'll see here is two balls. The first one, do you know what ball is this? Do you know what ball is this? Huh? What is this? Bowling ball. And this is football. Okay. Now let me ask you this. They are about at same size, so the size doesn't matter. Okay. We just assume that the ball is at same size. What is the difference between this and this ball? Instead of no, the size is we assume to be the same. What is the difference between this and this? Huh? Except the color, the structure, it doesn't. We put things. We put the different way. So what is the difference between this?
Mass.
Mass. That this bowling ball has greater mass than this ball. Maybe, who know, maybe this ball maybe 20 times, 30 times weight than this ball. Okay. What are they trying to tell us? An object with a bigger mass is more difficult to set in motion or stop from moving as compared to a lighter object. Do you understand? Do you understand? Do you understand? Somebody, what do you understand out of this sentence?
Objek berat susah nak kawal pergerakan dia.
Susah nak kawal? Susah
Ya.
nak kawal ke? Bukan susah nak kawal, susah nak apa? Mana ni yang sesuai?
Terima tadi.
Susah apa? Ni. Dia bagi tahu, katakan belah kanan ni, warna biru ni berat, lebih berat pada bukan berat, lebih tinggi jisim. Jangan guna weight. Weight and mass is different. Let's say this blue tip here is bigger mass than this black here. Okay. So the idea is, you know what? Let me ask you this. If you push both, which one that you find it difficult to push? The heavy one or the light one? Which one?
Heavy.
The heavy one here. The heavy one. You kind of push it. That is what they mean. Difficult to set in motion. Set in motion means that set in motion here means when you come to bring this from at rest or at stop to move. start to move, then it is difficult. But how about this? If you push this, is it difficult or easy?
Easy.
You want to set in motion this, easy, because the mass is lower than this. So the idea is, if I got another thing that is the mass higher than this. Let's say I got this eraser. This eraser is a bigger mass than this. Okay. Then between these two, which one is difficult to move?
Eraser.
Eraser. So the idea is, oh yeah, I know what you think that why do not mention weight? Why mention mass? Correct. Let's say we bring all of this in a space. Let's say we bring all of this in space. Okay. No air, vacuum. It means vacuum, and got no gravity. Which we know, if there is gravity, then there is a weight, correct? But this time we bring this tree to the place with which has no gravity and at vacuum. So now we cannot talk about weight, correct? Because there is no gravity exert on these three things. Okay, now you're going to do the same. Let's say here is in space, in space. Let's say here a new place in space. Now this has bigger mass than this, and this has bigger mass than this. Remember, we are in space, which weight doesn't count. We only count mass, right? We only count mass. So then you do the same. You're going to push this to set in motion. You're going to push this to set in motion. You're going to push this set in motion. Now let me ask you, which one is easier? Which one is difficult? Which one is easier? Let's say this is 1 kilo. Let's say this is 1 kilo. Okay, this is 10 kilo, and this is 100 kilo. Let's say, So you push all of these three, and which one is easier for you to push? Which one? 1 kilo, 10 kilo, or 100 kilo? Which one?
1 kilo.
1 kilo. Okay, which one is difficult for you to move? The most difficult. 1 kilo, 10 kilo, 100 kilo, which one?
100 kilo.
100 kilo. So the idea is, the higher the bigger the mass, the bigger the inertia. The bigger the inertia, the bigger the difficult, the more difficult to move it from rest to motion. That is the idea. Do you understand? And so, if they are at motion, if they already move with some speed, let's say, they already move with some speed like that. Let's say three of them, all of them move at same speed. Whatever the speed is, Okay, they move like that, Okay, with the same speed, let's say, same speed. Okay. Now, tell me, which one is easier if you kinda come from them and try to stop them, by pushing against them. Now tell me, which one is do you feel easier to stop from motion? Which one? Is it this 1 kilo, or is it this 10 kilo, or is it this 100 kilo? Which one?
1 kilo.
1 kilo, you find it easier to stop. Okay, correct. How about which one is the most difficult to stop, for you to stop?
100 kilo.
100 kilos. So this is difficult. This is in a middle. Okay, not so hard, not so easy. In the middle, because 10 kilo is between 1 kilo and 100 kilo. So what conclusion that you can make from this? What conclusion that you can make from mass and inertia? What conclusion that you can make between mass and inertia? Somebody? That the higher the mass, the higher the inertia. Which is this inertia telling us the if the mass high, then the effort to move things that in rest is difficult, and if it in moving, it is difficult to stop. Is what the effect of inertia that is high. The higher the inertia, the difficult to move the object, and when the object is in motion, it is difficult to stop it. Okay, and the inertia is higher if the mass is higher, and so vice versa. If the mass is the lower the mass, the lower the inertia. The lower the inertia means that it is easy. It is not difficult. It is easy. The easier, it is easy to move the object. And if the object is in motion, then it will also will be easier to stop the motion, to stop the object from motion. Now, can you relate? Can you relate between these two? If that is, if what happened to inertia if mass high, and what happened to inertia if mass is lower, and then you come to know what happened to this trying to stop, trying to move, if the inertia high or if inertia is low. Do you understand that? Can you relate? Can you relate all of them? Okay. So we got car here. Let's say we got car. This is car. This is car. And this is a bicycle. A car and bicycle. Now let me ask you. Which one is easier for you to push? Is it car or bicycle?
Bicycle.
Bicycle. Why?
Bicycle.
Why? Why? Give me the reason why. Because you just learn a physics.
Lighter than car.
Because the inertia, you now supposed to say, supposed to talk about, supposed to relate about inertia, because the inertia of bicycle is lower than inertia of what? Of a car. Okay. And then why is it if the inertia lower, then it is easier to push than the inertia that is higher? Why? Now you're going to relate back to mass, inertia and mass. How are you going to relate that? Because the mass of bicycle is lower. Thus, the inertia of bicycle is also lower. While the mass of car is bigger. Thus, the inertia of car is higher. This is how you relate between three of them. Okay. Now they are in motion. They are in motion with same speed. Let's say 10 km per hour. Okay. So which one is easier for you to stop? Bicycle or car? Bicycle. Okay. Now give a reason which use the concept of inertia now and mass. Give the reason why. Why is this bicycle easier for you to stop than the car? Why? How are you going to say that in terms of physics? Because the mass of the bicycle is lower than the mass of the car. Correct? The lower, then now you relate to inertia between mass and inertia. You say the lower the mass, the lower the inertia. The higher the mass, the higher the inertia. Correct? And this is how you relate to physics. You must say like that. This time you are a student of physics. You need to explain in term of physics. In concept of physics. Okay. The lower the, then you keep continue the lower the inertia, the easier it to the easier we can stop it from motion, and vice versa. The higher the inertia, the more difficult to stop it from motion. Do you see in this explanation which we relate to mass, inertia, and also difficult or not difficult from rest to motion, from motion to rest. This is how you going to explain when you come to explain anything that related to this inertia, any phenomenon that relate to this, any situation that relate to this inertia. Okay. Because in question paper, in paper, they will be some of this question they ask about, they required you to tell the explanation about this inertia. They're going to give some situation lah, which involve two things. One thing number one is lighter than thing number two, lighter than thing number two. So begin from that, you required to explain like that, which involve the word inertia and mass. Okay. Any question until now? When do we stop? 10:10 Is it 10:10?
Yes.
Yes.
Okay, moving along. Here some experiment to you, for you, that you can do to tell about inertia and mass lah, to study about inertia and mass. There is experiment that we can study the relationship between mass and inertia, and the arrangement of apparatus and material is like this, like this. Okay, simple one. So you got a, jigsaw blade or whatever that is, which can hold this loading. Okay. Example here, I got this ruler. You can do this at your home. You can replace this jigsaw blade by whatever that can hold the weight. If you put this, yes, of course, it's going to become curved like that, because all the gravity will pull the plasticine downward. But if you put it like this, in a straight like this, so guess what? It cannot be curved. It is difficult to be curved. So it's why this is also suit to do this experiment. So you kind of attach a plasticine at the end of this ruler. Then guess what? You're going to do like this. You're going to hold with the other end. You hold it with your fingers like this, okay, and let it move freely on the other hand like this. So guess what? If you put a weight, if you put a loading here, let's say plasticine, you put it here. And do I have a plasticine? I don't have plasticine, but can I use this instead? I have this. Let's say this is my plasticine, or whatever load that you can use. So you see, if I And this is how we're going to run this experiment. You're going to pinch a little like this, huh? And then you're going to release. So you'll see it going to oscillate like that, oscillate. Right, left. It go right, left, like that, okay? Right, left. So you see, okay? You can do this at your home. You can even do this now, Don't you have a ruler and something heavy to attach at the end, Can do it all together. Come on, like this. Everyone, come on, But this time, okay, good. This time, you know what? I really need you to do this because I want you to feel. I want you to feel. Not only look at them. Some of the experiment, you really need to feel it by your hand. Feel it yourself like this. So, everyone, do you feel do you feel interested in doing this? Okay. It move like that, fourth back like that, Yay. Kan? Yay. Okay. If you got plasticine, then that is better because you know what? I want you to do something about this load. I want you to do something. I want you to have 2 or 3. The more the better. I want you to have the load which is different in mass. Different in mass. Okay, Can you spare other thing which is either lighter or heavier than this one? So because I want you to feel what it is like if you oscillate with the bigger mass and the lighter mass. I want you to feel. Okay, by then I will have a opportunity to tell you what I want to tell you lah. Okay, now you change it to lighter object. Lighter object. All I got here is I got this ruler. I got this eraser. Here it is, which is more lighter than the tape that I use. I don't know how to attach that, but I can use the what is it? The what do we call this? String. Is it string?
Getah.
Tak dalam bahasa Inggeris. Apa benda? Rubber string. Whatever lah.
Yes. Rubber band.
Rubber band. Okay, rubber band. Okay, now I want you to remember that to be fair, you need to hold the same length, from your tip of the finger until the end of the load. I want you to be fair lah. If you hold 15 centimeter, then the second one you hold 15 centimeter too. Now I want you to try to vibrate this, and you feel him lah. You feel there. You feel there. Okay. Is there some different? Is there any different that you can point out? Is there any difference between heavy object and lighter object? Can you see the difference? Do you notice any difference?
The time.
Huh?
The movement.
The movement? What is it? The movement, to be particular. What is it? That you... Yes, it is about a movement. It is about a movement. What is it that you notice of the movement? What is it? To be precise lah, what is it? Now back to... You can change, change back to heavy, change back to lighter. Okay.
Yang berat tu susah nak iron.
I feel that too. Yang berat ni macam susah nak berayun je. Kan? Semua orang rasa yang sama ke? Do you feel the same, everybody?
Yes.
I feel, entah kenapa cikgu rasa di hujung jari ni macam ketat je nak bergerak. Kan? Okay, back to lighter, Okay. Do you notice anything else? Okay, pertama, betul. Siapa jawab tadi? Saya tidak. Bahawa kita dapat rasa di hujung jari ni, macam hak berat ni payah je nak bergerak kan. Macam ketat je nak bergerak. Dia, yang ringan ni kalau kamu change, rasa macam senanglah sikit kan nak bergerak. Kan? Ada lagi anything that you can you notice the difference?
Time taken.
Mana kamu dapat semua idea ni? Kamu baca buku ke? Kamu baca buku ke?
Tak ada.
Maksudnya, ya betul. Idea tu betul. Kamu perasan tak? Tadi hak berat, dia pergi dan patah balik lambat macam ni. Kan? Tak? Tapi bila hak ni semakin ringan, dia pergi dan pergi tu cepat lagi kan? Tak? Macam senang. Dia pergi atas, pergi bawah, pergi kiri, pergi kanan. Macam laju lagi lah maksudnya kan? Betul tak? Lebih cepat kan? Dia berubah arah tu lebih cepat kan? Nampak? Maknanya dia pergi ke kanan, dia berubah arah nak ke kiri tu, mudah je. Bila sampai kiri, dia nak patah ke kanan balik, mudah je. Macam tu. Yang lain semua okey? Ada buat ke tidak ni? Semua wajib buat. Kalau tidak, payah nak cerita ni. Kan? Back to heavy object again. Tengok. Masya Allah. Dia nak, setelah dia pergi kanan tu, dia nak ambil masa nak patah balik tu. Ya Allah. Lama. Macam ni sukar. Okey. Jadi itulah dia jawapannya. Maksudnya ialah lebih berat loading ni, berat, cikgu guna istilah salah. Jangan sebut berat. Sebut, kenapa tak boleh sebut berat? Sebab dia berayun kiri kanan kan. Bila kiri kanan dia bergerak, dia tak ada kena mengena dengan graviti. Betul tak? Jadi graviti tak ada bermain dalam cerita ni. Sebab dia bergerak kiri kanan. Dia bergerak atas bawah. Faham tidak? Dia tak bergerak atas bawah. Dia bergerak kiri kanan. Kalau kita nak bagi graviti kena mengena, kita nak sebut berat, kita kena buat dia berayun atas bawah macam tu. Okey Itu pasal lah pembaris dia kena ayun kiri kanan begitu, bukan atas bawah. Jadi jangan sebut berat. Kaitkan dengan jisim sahaja. Berat, kita dah hapuskan graviti, tak ada lah berat ni. Ni cara nak hapuskan graviti ni. Iaitu kita ayun dia kiri kanan, bukannya atas bawah. Okey. Jadi apa yang berlaku sebenarnya? Kenapa dia begitu liat nak patah balik setiap kali? Kerana jisimnya tinggi. Kerana inersianya tinggi. Kenapa inersianya tinggi? Kerana jisimnya tinggi. Jadi, yang kita setuju tadi, semakin jisim tinggi, semakin tinggi inersia. Semakin tinggi inersia, semakin... Apa berlaku bila sampai kat kanan ni? Dia susah nak dihentikan, betul tak? Sebab dia inersia tinggi. Jadi sebab tu dia berhayun lambat. Lambat nak ke kanan. Sudahnya bila sampai ke kanan, dia sudah dalam at rest lah kan. Dia dah berhenti dah kan. Dia berhenti sejenak tu, kamu perasan tak? Bila dia at rest, susahlah pula pasal jisim dia tinggi, maksudnya inersia dia tinggi. Kan tadi kita dah come to agree that if the higher the mass, the more difficult to set in motion. This time when it come to turn back, because the higher the inertia due to high a bigger mass, then it take longer time to return back. And so on. When it reach to the left side, because of the inertia is high, he want to keep moving remain in uniform speed, uniform velocity. So guess what? This is why the ruler is difficult to stop this motion, because high inertia to stop. So it goes like that. Terlalu berat. So that this is why it kind of stop slowly like that. Okay, before it come to rest, fully at rest like that. This time when it come to turn back, the same thing. Now this object is at rest. Now when it come to turn back, because of his high inertia, possess high inertia, means that due to high bigger mass, and so we come to agree that if it stop, then it is also difficult to set it in motion back. So it goes like this. Beratnya, nak tarik balik ni. Aduh. Okay, and the process is keep moving like that. Okay. Easy, but difficult to stop. And when it stop, difficult to move. When it come to move, then it difficult to stop back, and so on. This is why the heavier object oscillate not as fast as the lighter object. Okay, because very heavy. Once it stop, very heavy to move. Once it's moved, very heavy to stop. Like that. Not very heavy lah. You change heavy to difficult. Very difficult. Okay. Back change to lighter one. Wow. So quick. So easy. Okay. Because this is lighter, means that the object is lower in mass. Lower. So this is why when it at rest, it easy to set in motion. It is easy to move. While it is in moving, it is easy to also it is easy to stop. And now it's going to return back, and because it is lighter, lower mass, lower inertia, it is easy to set in motion from rest. Okay, and so the process keep moving like that, from right to left, from right to left, and lastly we'll see that the lighter object vibrate very easy and very quick, very quick. Okay, very quick. Tang, tang, tang. Easy to come, easy to go, easy to come, easy to go, like that. You understand me? Okay, so you know what? Remember this experiment. If question required you to do experiment involving to show the relationship between inertia and mass, you know already which experiment you should do. That is this experiment, simple tool, simple arrangement, and simple explanation. The explanation is simple, consists only in one sentence. Cannot you be able to explain like as simple as this? Only one sentence only. An object with a bigger mass is more difficult to set in motion, or more difficult to move from rest. And so if it in motion, it is difficult to stop from motion, as compared to a lighter object. Okay, again, this time we talk about lighter object. An object with a lighter mass is more easier to set in motion or stop from moving as compared to a heavier object. Simple like that. Okay, I want you to keep this sentence in your mind. Okay, you even can do it right now. Okay, take a time to memorize the sentence. A good way to say things. A good way to say the effect of inertia and mass. Okay, any question until now? You know what, we almost come to end this subtopic, inertia. You know what, this inertia involve no formula, involve no mathematics. It's only involve understanding of how Allah command, how Allah command the world. Okay, how Allah put the rule on the world, that we come to know that we know as inertia, or another name for inertia is Newton's first law. Okay, believe it or not, Newton is the first person to discover this, the truth from Allah Subhanahu Wa Taala. Okay, but unfortunately he is not a Muslim. Okay, unfortunate for him, not a Muslim. Okay, any question? Now we end this topic, subtopic, shall we? So after the experiment, we come to the generalization. Let's read this. Experiment 2.2 shows that the inertia of an object is related to its mass. See, I told you, inertia and mass. The horizontal oscillations in an initial balance are not influenced by gravitational force. As I told you, because we do the vibrate left to right in horizontal way, not in vertical way. The period of horizontal oscillation of the initial balance depends only on the mass of the plasticine. The mass only, not the weight. Means that if we do the oscillation, even at other planet which has different gravity, the period remain the same. You understand me? If we do the thing that we did before like this, but let's say we take this oscillation to another planet, let's say to sun, to the sun, planet of the sun. Okay, you know what? The period is remain the same. The period still the same. Okay, why? Because it involve no gravity. This inertia had involve nothing to do with weight. Nothing to do with gravity means nothing to do with weight. Only have something to do with mass. Okay, the larger the mass of an object, the larger the inertia of the object. The larger the inertia means that the difficult that the story about difficult or easier, easier to move, easier to stop. Okay. Do you agree with this last sentence, everyone? Do you now come to agree this sentence? The larger the mass of an object, the larger the inertia of the object. Everyone? Come on, say
Yes.
something. Okay. It's what I want to hear. So my teaching is not a waste. Okay. Now, you may ask. Lastly, what does this inertia have to do with our life? We'll see. Let me see. Astronauts in a space such as the International Space Station, ISS, are in a condition of zero gravity. Okay. Under the condition of zero gravity, only the inertial balance can be used to measure mass. Balance is what is balance? Balance is a tool, a tool to measure the inertia. Either it is light or it is high. Either the inertia is low or high. Can be used to measure mass. Photograph 2.6 shows a special type of inertial balance used by astronauts. The periods of oscillation of astronauts are used to determine their body mass. The periods. Do you understand this? Do you understand this last sentence? What is the idea? Now, let me ask you this. What is the mass of this tape? Let's say this mass of this tape is, let's say 10 milligram. 10 milligram. You know what? This 10 milligram, and let's say this is also 10 milligram. This eraser also 10 milligram. So the idea is, if we attach this and we calculate the period start from this, until it go and back to the same point. One way on this. Like that. Let's say it takes 5 seconds. And guess what? If I replace this load with this load, which we come to know the mass is the same, guess what? When we release it from the same angle, and it going to travel back to the same point here, how many time that it will take? Or what is the period? Guess what? The period is the same. That is 5 seconds. Before 5 second period, and we use this also 5 second. The idea is 5 second, the same mass, the same period. And the opposite way is, if the period is the same for different things, the idea is the mass of both is the same. Do you understand? So they kind of match. They kind of match between period and the mass. If the mass is, let's say, 1 kilo, if the period is, let's say, 20 seconds, the period of oscillation is 20 seconds. So they match this period coming from which mass. And they found out, let's say, it's coming from 50 milligram of mass. Only 50 milligram of mass will have this kind of period, that is 50 seconds, let's say. Do you understand this? By then they able to measure the body mass, just by looking at the periods of oscillation. You understand me? Okay, we have run out of our time, and there is a couple, several daily life need to be explained. Only a simple thing. Okay, don't worry. You can read it. You can read it yourself. To testify your concept that you hold correct or not about inertia. Okay, then we finish. We finish already. This chapter. This sub chapter, that is inertia. Okay, until we meet again. Assalamualaikum.
Waalaikumsalam.